So the last video that you watched was a little bit longer, and it was about naming branched hydrocarbons. So we took the idea of naming straight chain hydrocarbons like alkanes, alkenes, and alkynes like pentane, pentene, or pentyne. And then we added branches, so we did things like 2-methyl pentane or something like that. So that's a really important skill step that you went up, and now we're going to go up one more skill step, in which case we're going to talk about something called structural isomers. Now, to define structural isomers, structural isomers are compounds or structures that have the exact same chemical formula but a different structural formula. For example, the compound C4H10 has 2 structural isomers. One of them is butane, which is really easy to draw, which would be 1, 2, 3, 4, because it has but means 4 carbons, and ane means they're all single bonded. Okay, and then we would go and add the hydrogens. So this would be like NH3, NH2, NH2, and NH3. So this is one form of C4H10. There happens to be another form of C4H10, which is called 2-methylpropane. So what I see here is I see that I have A and E, so it's all single bonds. Prop tells me it's 3 carbons long, so I'm going to start with that. That's going to be my parent chain, 1, 2, 3. And then I'm going to bond them together, so they're all single bonded together. And then it says 2-methyl, so I'm going to add a methyl group on the second carbon. So when I count this carbon out, it is, or this chain out, it's 1, 2, 3. So on the second carbon, it's going to have a branch that comes off, and I'm going to add a carbon, or a methyl branch, which is a 1 carbon long branch, and it happens to be on the second carbon. So now I'm going to go back and add hydrogens. The first carbon has 1 bond, so it needs 3 hydrogens. The second carbon has 3 bonds, so it only needs 1 hydrogen, and the third carbon has 1 bond, so it needs 3 hydrogens as well. And then the other carbon that's present is the one on the methyl, and the methyl branch carbon only has 1 bond, so it looks something like that. Both of these structures are the correct chemical formula, or the correct structures for a compound that has a formula C4H10. However, they both behave pretty differently. Butane, as you may be aware, is lighter fluid. Like when you light a candle with it, it creates a flame. Propane, 2-methylpropane, is a coolant, which is actually the opposite of what butane does. So even though they have the same number of carbons and the same number of hydrogens, they both do 2 very different things. So we're gonna do one example, and then you're gonna have the rest of the time to do homework, or the rest of the assignment is homework on this, and we're gonna name and draw the 5 structural isomers of hexane. So I know that hexane has a chemical formula of C6H. C6H 14. C6H14. So I'm going to take some time and I'm going to draw all of the possible combinations for that. So what I'm going to do is I'm going to start with what would be the easiest, and I'm going to draw the structural isomer that is just hexane. So I'm going to go 1, 2, 3, 4, 5, 6 carbons long. I'm going to single bond each of them together. And then I'm going to go back and I'm going to add hydrogens so that each carbon has 4 bonds. So this is CH3, CH2, 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 CH3. Now, that's going to be the structural isomer of hexane. It has 6 carbons, and they're all single bonded together. So then when I go ahead and draw a different structural isomer of hexane, what I do is I remove one of the carbons and I make it a branch. So if I remove one of the carbons, it goes from being a 6 carbon long parent chain to a 5 carbon long chain. So 1, 2, 3, 4, 5. And then I'm going to bond them together singly, just like we've been doing. And then I'm going to add a branch. And I'm going to count these carbons. 1, 2, 3, 4, 5. And I'm going to add a branch, not on the first carbon. Because if I add a branch on the first carbon, even if I make it go up, or I make it go down, or I make it go to the left, basically what I'm doing is I'm adding to the end of the chain and I'm making it have 6 carbons, so it's hexane. So I'm not going to put it on the first carbon, I'm going to put it on the second carbon. So here is a 5 carbon long chain, which would be pent, and it's all single bonded together, so it's a pentane. And on one of the carbons there is a branch that has a 1 carbon long branch, that's a methyl. So I see that this is going to be a methyl pentane in some way, shape, or form. So I'm going to just write that. Oops. And the location of the second branch is, or the branch is on the second carbon, so it's going to be a 2-methyl pentane. I do need to make sure that I go back and I add all of the appropriate hydrogens. So the first carbon needs 3 hydrogens, the second carbon needs 1 hydrogen, the third carbon needs 2 hydrogens, the fourth carbon needs 2 hydrogens, and the fifth carbon needs 3 hydrogens. Now, that first branch also needs to have a carbon with 3 hydrogens. And what's important to hopefully identify here is that even though it's a different shape, it's actually a different molecule. So now the next thing I'm going to do is I'm going to move my branch, and by moving my branch, I can create a different structure, but it's going to look similar. So the next thing I'm going to do is I'm just going to move my branch 1 step over, which would be 1, 2, 3, 4, 5 carbons long. And each of the carbons are single bonded together. And then I'm going to number my chain 1, 2, 3, 4, 5. So those are my 5 carbon long chain, and I'm going to add a branch on the third carbon. And by adding a branch on the third carbon, I still have a C6H14 eventually, but it's a different structure still. So I'm going to go ahead and add my hydrogens. This is going to be H3, H2, H, H2, H3, and H3. And because the longest continuous chain of carbons is 5 carbons long, it's still going to be a pent. And they're all single bonded together, so it's a pentane. There is a branch, and it is a 1 carbon long branch, so it is going to be, again, a methyl. But this time, the methyl is on the third carbon. And so that makes that, so now we have 3 different structures for the same formula. And now I'm going to move the branch 1 more time. So it's 1, 2, 3, 4, 5, and I'm going to single bond them all together. And then I'm going to add my branch, so I'm going to count. It's 1, 2, 3, 4, 5, and then I'm going to add my branch 1 step over, which would be, let's see, 1, 2, 3 on the 4th carbon, and so it looks something like this. And if I do this, this is actually 100% incorrect, because it's no longer going to be a 4-methyl pentane. It's going to be a 2-methyl pentane, because we always count closest to the branch. So this doesn't work at all. So what I'm going to do is, when I've gotten to the point where I've exhausted all of the different ways I can move a branch, I am going to, that's weird, why won't this erase? Okay, that's strange. that's not what I want. This is not the best way to do this. But what I'm going to do is I'm going to remove one more carbon. And when I remove one more carbon, it goes from having a 5 carbon long chain to having a 4 carbon long chain. So that would be 1, 2, 3, 4. Going to single bond them together. 1, 2, 3. And now I've got 2 carbons that I can make branches. So the first option that I'm going to do with that is I'm going to number my chain. 1, 2, 3, 4. And for me, it makes sense to take and add a branch here and a branch here. So I have 2 methyls. Now, what if I would have done this? What if I would have said, instead of I would did this, okay, so if I do that, I still have a 5 carbon long chain with a branch on the second carbon. So that's not what we want at all. So we are going to add the 2 methyls, like so. And then we're going to add hydrogens. So the first carbon is in 1 bond, so it gets 3. The second carbon is bonded 4 times. The third carbon is bonded twice, so it gets 2 hydrogens. And the fourth carbon is bonded once, so it gets 3 hydrogens. And the methyl branch will get 3 hydrogens on each methyl branch. So now I have to remember that these are all single bonded together, so they're ane. And the number of carbons in a row is 1, 2, 3, 4. The prefix for 4 is but, so it's going to be a butane. And I do see that I have some methyl branches, so I'm going to add YL, and they are 1 carbon long each, so it's going to be methyl, but I have 2 of the same type. So in that case, because I have 2 of the same type, I have to add the other prefix di. And when I add that other prefix di, that also tells me that I have to tell the location of where both of those branches are. So this is going to be a 2,2-dimethylbutane. And so I told you that there were 5 total structures that you could draw for hexane. So we're going to go ahead and do that now. And I don't need to remove another carbon, because if I take one more carbon away, what I end up with is no matter where I put it, I still get a 4 carbon long chain. So I'm going to take one of the methyls and move it from the second carbon to the third carbon. But I'm going to start with my parent chain, which is 4 carbons long. And I'm going to bond them all together singly. And I'm going to add the first methyl branch here, because I can, on the second carbon. 1, 2, 3, 4. And then I'm going to add another branch on the third carbon. And it can go up or down. It actually doesn't matter. That's not what we wanted. Go up or down. It actually doesn't matter. I'm going to make them both go up, so I have room to write down below. And then I'm going to have a carbon here and a carbon here for my methyl branch. Now I'm going to go back and add my hydrogens. Here's 3 for that carbon. Oh, not 2. That wouldn't be 2. That would be 1. And this one would have 1. And this one would have 3. So that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So C6H14 once again. So now I'm going to go back and rename my structure. It's going to be all single bonds long, so that it's an ane. And it's still 4 carbons long, so it's a butane. And there are 2 methyl branches, so we have the YL and the prefix meth for each having 1 carbon long branch. And because there's 2 of them, it's going to be dimethyl. And now we have to identify their true location, which in this case is 2,3-dimethylbutane. So that's how this particular skill set works. You simply just draw the easiest chain, take 1 carbon off and make it a branch, take another carbon off, make it a branch, take another carbon off, make it a branch, until you've exhausted all the possibilities. The reason why I wanted to take the time to show you this particular part of it is because your homework is to draw the 18 isomers of the chemical formula for octane, which is, I believe, C8H18. That will be posted, and go ahead and draw that, and good luck, and we'll see you for the next lesson.